Hey everyone, in this video we're going to be solving some quadratic equations and we're going to be using the graph to do that. So our goal, by the time we're done here, we want to determine the number and identity of solutions from the graph of a quadratic function. So even though we will have our equation, and in fact you can see here, this is the equation for this quadratic, and we are going to eventually focus on solving a quadratic using nothing but that equation. For right now, we're going to solve it by looking over here for the graph first. That'll help us understand what we mean by the solutions to a graph, and will just help conceptually and allow us to check some of our work later on. So let's talk about solving an equation. And this equation that you see here is a linear equation, one that you already, in theory, know how to solve. You've got this. It may take a second to brush off some cobwebs, but you've got this. So when we solve an equation, we're finding the value of a variable that makes a statement true. So if I have 3x plus 2 equals 8, I would subtract 2 from both sides. That would leave me with 3x equals 6. Then to isolate the variable, to get the x by itself, I would divide both sides by 3, and I would find that x equals 2 is my solution. I've now solved that equation, and what that means to solve the equation is that if I replace the x with that number, my equation will come out to be a true statement. So 3 times 2 is 6. 6 plus 2 is 8, and 8 does in fact equal 8. So again, when we solve, we're just finding a value for x that makes the equation true. Well, when we're dealing with a quadratic, that is still the case. We're still looking for the value of x that makes the equation true, but for a variety of reasons, that being true means is what happens when it's equal to 0. So when we look at an equation, for instance, y equals x squared plus 2x minus 8, if we're going to be solving this quadratic equation, we're going to replace that y with a 0, and we're going to try and solve this right here. Now the problem with that is that we have no way yet of algebraically dealing with that x squared. So we have some things that we have to learn to do in order to solve this from the equation, but from the graph, not so many problems. All we have to do is get the graph of y equals x squared plus 2x minus 8, and to solve it, to find the places where y is equal to 0, well folks, if you stop and think about this for a second, you already know what we call the places where y is equal to 0. Those are our roots, or x-intercepts. And I'm going to make things more complicated by dropping 2 more vocabulary words that mean the exact same thing on you. Roots and x-intercepts are also called solutions. Check that out and let me repeat it. They're called solutions. And they're also called zeros. So if we're asked to solve a quadratic equation, that means we are looking for the solutions, means we are literally just looking for the x-intercepts and the roots. So if we can find a graph, and we can find the places where those cross the x-axis, we have solved our quadratic equation. And it is literally that simple. Now, one thing that's not necessarily in my slide presentation here, but I want to throw out to you, is the fact that you have a very powerful tool for your disposal to do this. If you go on the internet to the Desmos website, D-E-M-O-S, so desmos.com, what you'll find is a graphing calculator where you can type in any equation that you want to, and it will graph it, and it will have very nice tools for navigating around that graph and finding those x-intercepts. So push come shove, you can always put an equation into Desmos, look at the graph, find the x-intercepts, and those, friends and neighbors, are the solutions. But let's look at a few more traditional type problems for this. Example 1, solve the quadratic y equals 2x squared plus 4x using this graph. So again, when we're asked to solve, all we are really looking for are the roots, the x-intercepts, also called solutions, also called zeros. So I can find those two places there, and specifically what I'm interested in is the x value, because we know the y value is always going to be 0. And so here the x values that make this true are x equals -2 and x equals 0. Notice how I wrote those. X equals some number and x equals some other number. Those are the roots. This is the most typical presentation that I'm going to ask you for. So when I ask you to solve, this is what I want your answer to look like. However, since we are just finding the roots of this thing, it's not incorrect to say that my solutions are -2, 0 and 0, 0. These mean the same thing. We're just interested in the x value, and here I've given the y value, but it's not wrong. It's just extra information. And so you can present your answers either way. I have a very slight preference for this one right here, but neither one of these is wrong. So again, to solve that quadratic, all you're doing is looking for the solutions. And remember, when I said we solve a quadratic, that means we're letting y equal 0. And that when I substitute these values in for x, that I should get a true statement. So let's start by substituting in -2. And let's watch what happens. -2 squared means -2 times -2, which is +4. 4 times 2 is 8. And then 4 times -2 is -8. Well, 8 plus -8 is 0. So -2 does in fact make this statement true. So it's a solution. We can try the same thing with 0, but I bet you have some idea what's going to happen here. So 0 squared is 0 times 0, which is still 0. And 0 times 2 is still 0, not going anywhere. Plus 4 times 0 is 0. And 0 does in fact equal 0, so that's true statements. Now when you're giving your answer, you only have to give this up here. I'm only going through all of this process to show you that when I substitute those values into my equation, which is set equal to 0, that I get a true statement out of those. So let's look at a few more examples to make sure we really get what's being asked for here. For example 2, solve the quadratic y equals -x squared plus 2x minus 1 using the graph. So I'm looking for some value, x equals, and I just want the root. Notice I said singular right there. There's only one root. This is something that can happen. Whereas on the previous problem, we had 2 roots because it passes through the x-axis twice. It's also possible that it only passes, or that it only touches the x-axis once. This will happen when the vertex of the parabola is on the x-axis, in which case there is only one root, so my solution is just x equals 1. That's it, we're done. Let's look at another example, example 3. Solve the quadratic y equals -2x squared minus 4x minus 3 using the graph. So we want the x-intercepts, the roots, the solutions, the zeros. We want where it crosses the x-axis, and it doesn't. So when this happens, we say there are no real solutions. A couple things I want to clear about this. It's not that the solution is 0, because if you say that, that means it touches the x-axis at 0. That's not what's happening here. We're saying there are no solutions, but notice this word here. I say there are no real solutions. Now what I'm going to tell you is why we have to say there are no real solutions, even though it's not going to make a lot of sense to you right now. It will when you come to Algebra 2. There are no real solutions to this quadratic, but there are what are called imaginary solutions. And I'm not trying to be cute. That is actually what they're called. And so there are imaginary solutions to this quadratic, but there are no real solutions. So we must say that as part of our answer. And if the graph doesn't cross the x-axis at all, there are no real solutions. So to recap, if we're solving a quadratic, all we're doing is finding values of x that make the equation equal to 0. And those points on the graph are the roots, which are also known as x-intercepts and zeros and solutions. And a quadratic can have 1, 2, or 0 real solutions. So you might get 2 answers, you might get 1 answer, or there might not be any answers. Alright folks, work hard, practice hard, study, make sure you know all of this. There's a lot of vocabulary, there's a lot of conceptual things going on here. Most of the work has to happen between your ears and it may not show up on paper. Make sure you're learning this. Good luck.